Okay, welcome everyone. Welcome to the GAF Sustainable Roof webinar. Wanted to do some quick introductions and just welcome everybody in. Also, if you could put in the chat your name and which firm you're from. We always like seeing that as well. My name is Melanie DeCola. I am the Climate Pledge Program Manager Director here at AIA, which includes the 2030 commitment, which we'll be talking a little bit about today, and the Materials Pledge as well. So I wanted to welcome you all here, and I am going to kick it over to Jennifer Keegan, who's the Senior Director of Roofing and Building Science for GAF.
Thank you. First, I wanted to start with a question. How many of you have been here losing your sustainability goals to the budget monster, right? You come up with this beautiful design, you've invested so much, and it's not just a loss of great work, it's feeling defeated in this bigger picture, because this is our collective future. And so how do we prevent this from happening, or at least increase our odds here? So what if the conventional roof that you specify for a high profile living building challenge project like this Stanley Center, what if it's the same roof that you put on multi-use buildings, such as this Goodwill of the Great Plains headquarters? So we're going to talk about that today. So like she said, Melody said, I'm Jennifer Keegan. I am the Senior Director of the Building and Roofing Science team for GAF and CPLAST, which means we're the team that gets to engage with you guys, help out with performance and design of roof assemblies. In the background with me is Andy Wagner-Watts. She's in the chat and is going to be here to kind of answer any questions that are going on in the background while Jeff and I take things over. But Jeff, you wanna introduce yourself?
You betcha. Thanks, Jen. Yeah, I'm Jeff Terry. I'm the Vice President of Sustainability and Corporate Responsibility for GAF. So work very closely with Jen and Andy and our whole building and roofing science team, as well as our commercial and residential businesses, and integrating sustainability through everything we do, from our operations to how we design, develop kind of our products, think about our portfolio into the future, and then ultimately ensure that we embed life cycle thinking and analysis at the core of our entire portfolio, so that we're designing for the future the best products possible, and ultimately bringing them to the marketplace to ensure we have a better built environment tomorrow, 2 years down the road, 5 years, 10 years, 30 years down the road. It's great to be with you all today.
Great. So this is what we're going to cover today. We are going to talk about the setting of sustainability goals, the product-specific embodied carbon study that we're really excited to share with you. We'll go through some case studies to really show how this works in reality, and then wrap things up. So I'm going to turn it over to Jeff to set the table.
So, having worked in the field of sustainability for more than 30 years, I think it's, and you all experience this every day, and Jen set this up perfectly, is kind of sustainability is at the nexus of trade-offs. And the trade-off conversation is around budget, and it's around environmental performance, but those don't have to always be competing dynamics, and I think a lot of that starts through the very onset of a project, and incorporating and embedding kind of project sustainability goals right at the outset with all the key stakeholders, from owner to GC to manufacturing partners, and ultimately AIA has played a critical role in this over the years as well, kind of in convening kind of the material pledge, and thinking about Architecture 2030, in looking at the Carbon Leadership Forum, and really kind of there is a balance of this, but ultimately at the core of so many of the decisions around material or product performance, building performance, project performance, ultimate built environment performance, there are some key tools at our fingertips to leverage that we as manufacturers and others are increasingly focusing on, ensuring is available to you and to your clients, so that the best decisions can be made to really help focus on efforts like reducing overall carbon in the product, whether it's from operational carbon or embodied carbon, minimizing material, especially hazardous material incorporation into a project, recycle content. How is resiliency designed and built into and ultimately fulfilled through the project? And a few of the key components that help you achieve that are the LCA, the life cycle assessment tools and outlets and disclosures that come with that, whether that's environmental product declarations, it's declare labels, it's third-party certification on any disclosure on that product. As a manufacturer, we take very seriously this work, but we're also not going to be a manufacturer that just says, trust me. We want and believe in the verification of work by credible third-party disclosure and certification auditors and bodies that say, yes, when a manufacturer says we have this much recycled content in our product, we can show you the audit that demonstrates that, as opposed to people who just say, believe me. So, let me dig in. I'll jump into the next slide a little bit here, Jen. And, when we talk about environmental product declarations, essentially the marketing document of a product's life cycle assessment, we know that this is a mechanism that just doesn't help achieve green building certification. It can actually be an important tool for you in comparing the performance of products and how we think about roofing systems, not just products. And we're excited to talk a little bit more about that today, but we're seeing a greater demand for EPDs. A recent study conducted by One Click LCA earlier this year introduced or resulted in some of the findings that you see here, that increasingly EPDs are a tool being utilized to help determine material and products being used in your projects. And we only see that trend increasing. And frankly, on the next slide, there's still not enough manufacturers doing this work. And what I mean by that is doing the life cycle assessment work, not just to get an EPD, but to truly understand the life impacts of the product or the environmental impacts of the product, to ensure that they're improving that portfolio. We've been on a journey as a company for 10 years now, leveraging and utilizing LCA as a tool for designing a better portfolio that you have at your fingertips to design your projects and ultimately create a better built environment. But what you see here is there's still a lack of manufacturers doing this work to the extent that they need to. What I'll say about this is we saw about 10 years ago an initial movement towards EPDs, but they were also industry average. It was, how do we take the sum of all parts and put them into one comprehensive LCA that says, hey, here's TPO, single ply membranes. Here's what you can expect an environmental impact associated with that product is across the whole sector. It's not good enough anymore. This commitment, this work by manufacturers, identify those manufacturers that take this work seriously, because honestly, those who are doing product specific EPDs have the products to back up a better built environment from an environmental performance, as well as from an overall building performance perspective. So I'm spending a little bit of time here because I think it's really important. And kind of, yeah, Jen, you wanted to add?
Yeah, I'm really curious, how many of you are leveraging product-specific EPDs? So if you can put in the chat, that would be, I'd be really curious, like, is this something you guys are leveraging in your work? Is it something that you're seeking out? Is it something you find easily? Or is this something, that is kind of the missing link in the process here? So I'll give you a second to put that in the chat. And Jeff, if you want to kind of
Yeah,
switch into this study that we've done, which is really compelling.
I'll definitely do that, Jen. Thanks. And, I think the product specific EPD and disclosure requirement increasingly is becoming a part of lead V5, for example. So there is there's a push and a pull, a push by leaders and a pull by the sector in kind of continuing to improve the environmental performance of the built environment as kind of represented in lead V5. Moving forward, what I will say is, we don't look at this just at the individual product level. One of the critical kind of approaches that we've seen to take is because roofs aren't necessarily kind of built just one product at a time. You guys know that as well, if not better than us. It's about building a system. How do we build a system? So what we've done is we launched into a study about a year ago, and you can jump to the next slide if you like, Jennifer. Kind of with at the time kind of Cove, who was doing a lot of analysis around building performance and looking at ASHRAE kind of 2019 baselines and equivalent industry standard systems. We looked at 6 different roof systems, kind of 3 TPO, 3 PVC, and then kind of how we referred to them as good, better, best. So we've always believed that at the very kind of base and core of our product and our systems, environmental performance is paramount. And that kind of the investment that we make in our very basic portfolio products and portfolio systems need to have environmental performance better than none. And that's kind of was at the heart of why we did this research and saying, how do we look at kind of the performance of a good, better, best system that is a TPO and ISO system or a PVC and ISO system, and then compare that essentially to the industry average and then other materials out there. So I'm going to share with you a little bit about this. How we did this, and jump into the next slide, was we looked at all the climate zones across the US. And we looked at the International Energy Code, incorporating that in here, as well as doing a comparative evaluation of all the product specific and industry average EPDs out there to determine how roof systems actually compare. We didn't do it. Cove did this work. We submitted all of our data to them, and they did all the evaluation on them. So this gives you a picture of the climate zones that we analyzed, and kind of, so here, that's the drum. Sorry, that's terrible. I apologize for that. It's getting late in the week, but so we were looking at 2 things: equivalent energy performance. So based on similar kind of energy requirements for that specific zone, and ultimately, to the next slide, kind of the embodied carbon performance. And what we experience is that our systems and this is a kind of our base system comparison that we've essentially seen in comparing kind of our TPO and our PVC and our polyiso insulation product to the industry average TPO and PVC and ISO, a significant reduction in embodied carbon. And this is a picture of the percentage of lower embodied carbon from the industry average. So if you're looking in a climate zone 6, for example, our TPO system with polyiso and the base system here, and I'll touch on the base system in the next slide, but we are 45% lower embodied carbon than the industry average. On the PVC, equivalently in zone 6 were over 46%. So that's significant. You know, there's a lot of incentives at the state and local level and municipal levels around demonstrate kind of the embodied carbon improvement that's at least 20% better than the industry average. And there can be tax incentives available to your client, to the building owner, to that property owner. That was a little bit of, okay, where do we stand? We did this research to understand where we may land so that kind of one, we're demonstrating whether the work we're doing in product development, research and development is actually delivering the results we've been intending to. But ultimately, this now is a tool and a system that is at your property owners, your clients' fingertips and yours to say, we can help achieve these lower embodied carbon goals we have for the overall project. Here's the role the roof can play in doing that. Sorry, the GAF roof can help in doing that. Sorry, that was a shameless plug. Anyway, let's jump to the next slide, Jen. So we didn't just stop there. We didn't just look at kind of the comparative analysis of same product to our industry average. We looked at competing materials in the insulation. And this just gives you a snapshot of kind of what was important about this and informed kind of the comparison is that not all thicknesses are created equal. You know, the amount of material that's used, whether it's polyiso or EPS or XPS or mineral wool, that, you know, there's different thicknesses required to meet the energy code kind of specification, if you will, for that climate zone. So, and this is a snapshot of what we did there. And jump into the next slide, please, Jen. And again, this is our base system. So this is a 60 mil single ply TPO mechanically attached to 2 layers of 2.5 inch polyiso insulation. That's the base system. And then compared that again to the industry average, as I shared with you before, and then to EPS, XPS, and then mineral wool. And you see again, an equivalent significant improvement clicking through to the embodied carbon savings and lower embodied carbon associated with kind of that polyiso system, that TPO polyiso system. Jen, could you click to the next and have those numbers pop up? So on average, around 42% over industry average. Again, this is nationwide. This isn't just one climate zone. This is an average, but a 16% kind of reduction to EPS, 64% reduction of embodied carbon to XPS, and 77% embodied carbon reduction to mineral wool. So
I'm really curious, Jeff. What roof insulation are you that are listening in? What are you specifying? Polyiso is about 70%, 75% of the insulation utilized on roofs. But you know, there's areas where different choices are made, and so I'm curious where this group lies in terms of your product specification type for roof insulation. So if you could put that in the chat, that'd be good to know.
And the one thing I'll add here, this is our base polyiso product. This is not even the non-halogenated polyiso project in this base assessment here. That would show even greater performance. Jump into the next one. So the product specific kind of, and again, looking at these, this comparison, this just dives in a little bit more deeply into those 3 other material comparisons as well. So maybe jump to the next one. So here's a bit of the snapshot as it looks at all the comparisons that I've just shared with you around kind of again a TPO or PVC single ply membrane with kind of the base polyiso system. So 2 layers of 2.5 inch, and this is comparison versus all of those industry average as well as other insulation materials by climate zone. So this is wherever you may be in the country, kind of take a snapshot of this, or you'll get this kind of as a follow-up. And this gives you that comparison based on the energy requirements in that climate zone, where the embodied carbon kind of improvements are with our system versus all of these competitive materials. So this is, I won't go into all the numbers on this, but certainly this is kind of a good snapshot that gives you the picture. And we have about a 190-page report that goes into every single one of these comparative analysis that you can get out of our document library and our website as well. And then lastly, kind of digging in, you know, we didn't just do this assessment on our standard assembly. We did it versus an upgraded assembly, which included a cover board here, which you see here. And then we ultimately did a final comparison with our NH polyiso with a vapor barrier as well as cover board and thicker single ply membrane as well, all experiencing kind of equivalent performance, if not even greater performance, as you can see here. Kind of that better system, the one that I just shared that incorporated the cover board, actually we see a 50% reduction in or improvement in carbon, embodied carbon savings. So kind of with that, there's a lot I just shared with you. There's a lot to dig in here. We're very kind of excited about this data because it goes beyond just that product specific kind of environmental performance, and it looks at the full roofing system performance. And again, there's trade-offs, but this is the type of research kind of work and kind of effort we want to do in partnership with the architectural design community to really help kind of property owners, building owners set their goals and realize how kind of the roof plays a role in an overall project's sustainability performance and achieving, whether it's the green building goals they want, but the goals that they've set for their projects, or green building certifications they're looking to achieve, or ultimately helping to make the case for why green and sustainable and sustainably designed and built buildings actually perform better for them, as well as their tenants, their customers. We're here to help kind of partner with you and kind of making the case. We've got a lot of research. We've been doing this for years to really help ultimately the whole value chain of the built environment recognize and realize that you don't have to always make the trade-off against sustainability or sustainable design. It actually pays off for you. With that, Jen, I'll kind of turn it right back over to you.
Thank you. And it really set the table for the conversation through the lens of data, right? Because while we would all love to work on those living building challenge projects that are kind of the creme de la creme of the sustainability world, the largest argument I hear in terms of why we are not going to proceed with all the sustainable elements comes down to money. And if somebody else is hearing a different argument, please put it in the chat. I am very curious if it's something besides cost that becomes the roadblock from making the right decisions and the right choices. So I want to focus on here this Goodwill project, which is the Goodwill of the Great Plains. And this is Goodwill on multiple levels, right? It is a charitable organization. The purpose of their building is beautiful. and they were able to make sustainable choices in a budget constricted project. So a little bit about this project. It's not your typical Goodwill where we're dropping off our donations. This is actually a multi-use building. It has an adult daycare in there, as well as some of their offices. And their requirements for this project were that it was accessible on both cognitive and physical capabilities, but it was also net zero. Okay, so let's dig into that a little bit. Well, we have a bunch of design choices here, right? And this was a project designed by CMBA architects. And they wanted a robust design with a mindset towards the ease of installation. So this is the assembly they came up with. We have a vapor retarder at the deck level. We've got 2 layers of polyiso membrane that are mechanically attached. We're adhering that HD polyiso cover board, and then we have a self-adhered TPO membrane. So as we talked through the architects, what they were really looking to achieve was both the reflectivity in the TPO membrane, as well as the properties of the vapor retarder that's installed as an air barrier in this scenario here, is really helping to reduce the strain of the building's HVAC systems. And so that's resulting in not only saving on energy and the cost of energy, but also equipment maintenance cost, right? Because we're not overstressing this equipment. Now, in this project, as we have in most projects, we get down to that value engineering conversation. And in this case, they were really able to hold on to value. And when the contractor said, look, let's get rid of the cover board, I don't know that that's going to be like, we can save a bunch of money doing that. And they said, well, wait a minute. This roof is covered with 90% of this roof is covered with solar panels. The power of having this cover board underneath the membrane is really essential, not just for supporting the added weight, but for the foot traffic and ensuring long-term performance. And by the way, why wouldn't we choose an HD ISO board that's going to give us that extra R value? So they were able to shift this into long-term view and decision-making, and not just cut out critical elements of this building. So the next layer is the impact that these design decisions have on that human and environmental health. And we can really lean into that when we're making decisions with intention, like we did on this project. And this was not a living building challenge project, right? They didn't need to comply with all of these elements, but they chose to do the right thing. They chose to say, what can we do within our budget? Now, this is not a crazy over the top assembly, right? Like it does have the vapor retarder, which is important for many other reasons as well. But all of these layered into having this great impact. We're thinking about recyclability, durability, minimizing chemicals of concern, and what are the trade-offs that we need to have in these conversations. So with this assembly, we look at all the environmental certifications that we can have in here. So we have third-party verified ingredients through our insulation and the roof membrane. Also third-party verified recycled content for that insulation and membrane. We have product-specific EPDs that are certified, not just produced by us, but they are certified for both the insulation and the membrane. And then the resiliency is really layered in there with that HD, the non-halogenated polyiso cover board.
Hey,
So,
Jen, can I
yeah.
add on there too? And you know,
Please.
with the vapor retarder, we actually have kind of Green Guard Gold certification for low emittance for low emittance with that vapor retarder. I think it's the only vapor retarder on the market that has that UL Green Guard Gold certification. So there's just another kind of added element into this assembly as well.
Thank you for that. So this, this pretty, this is a good roof system, and look at all that we can accomplish with this, all of these certifications on this effort. So there are ways that we can do this. Now, how can we improve this? And I'd love to see somebody chime in the chat. Like, what would you do to take this roof assembly to the next level? So since I can't actually get you all to talk to me, challenge of video transmissions here. To us, the next step in this iteration is using that non-halogenated polyiso, and that's both in the insulation and the cover board. Now, using that can really have the significant impact in the human and environmental health, as well as our longer term performance. So with a non-halogenated material, we're red list free. There's no reduction in R value at low temperatures. And this is available in both regular and the regular ISO and the high density. So in this scenario, this is how we could take it to the next level. And spoiler alert, there's no added cost to doing this. Jeff, you want to tell them why? Like, I think this is the best story, and I know you were so instrumental in making this happen, so I don't want to steal your thunder.
No, there were a lot of people that were very instrumental in making this happen. But, you know, ultimately, kind of at the core of building sustainability from the ground up, or we'll say from the roof down in your project, it takes everyone. So it was years of engagement with our suppliers to say, how can we kind of change the material makeup of our polyiso insulation to ensure that we have we take red list chemicals out of that. So we are constantly analyzing what's coming kind of in the global red lists and saying, okay, how do we start designing ourselves for a future product or system that won't have any of these kind of one day. And ultimately we had a supplier that kind of came and said, this makes all the sense in the world. We see the future here. Let's build the relationship with you and with us so that, you know, it's going to be no different cost associated with that. And ultimately that's where the future of building sustainable solutions into the mainstream becomes just the regular everyday cost of doing business. Kind of NH, non-halogenated polyiso insulation, is a great example of that reality coming to the built environment. And it just takes everyone from hearing this from you, hearing this from property owners, and saying this is what we need to do to improve a roof system, to us kind of working with you to understand what does that mean? What does it take to do that? And then us working with our suppliers to say, help us get there. And this is going to be beneficial for you as well. And, you know, we do that in a way that ultimately brings kind of the future of the built environment to the present. And that's where we are with NH polyiso as a new key. Jen, to your point, same cost as kind of where traditional polyiso had been product to the marketplace.
Right. So we've now removed that value engineering conversation that the contractor is going to say, we're going to take this out. That's gone. That argument is now gone. And this is a really great way you can hold this part of your design in the project because there are no additional cost implications. So one other thing I wanted to mention about this project, this Goodwill project, right? It's up in Iowa. And so we're in climate zone 5. So climate zone 5 is a moderate to colder climate. We've got full on seasons, we've got cold winters and hot summers. So the insulation and the moisture control are really key to managing our energy costs and the tenant comfort. So this means that this project needed to be very focused on having that tightly sealed building enclosure with continuous insulation, which is why you saw that vapor retarder there at the deck level, because we needed that as part of the air control layer to make sure we were sealing that out and not allowing any moisture up into that assembly or into the building, and to prevent that condensation risk. So let's see. So this is some data that we pulled together through this this study that Jeff was sharing with you. So this is embodied carbon reduction this is for a bunch of different building types: data centers, hospitals, warehouse, retail, right? Because we're just looking at insulation here. So if I look at the embodied carbon of industry standard polyiso insulation, this is kind of the volume of embodied carbon. What does that look like when and so this is the dark blue is the polyiso, this medium blue color is the TPO membrane, right? So this is just industry standard products. Now, if you were to specify specific products and using our product specific EPDs, this is a pretty significant reduction. And this reduction is, you're going to see in the polyiso. This is a 49% reduction. So we really see that the insulation has such a big part of this. Now, from performance standpoint, I'm always going to advocate to have a cover board, especially when we have rooftop solar. So here, if we add in the HD cover board on the top, so yes, it's adding R value, but it's also adding to the greenhouse gas emissions, but that's still a 40% reduction. So this is still really try that again. This is a really considerable reduction that we can have just by being intentional on how we specify, and really encouraging the manufacturers you're working with to produce the data you need to make these kind of resilient design decisions. So material choices matter, right? This is where we had talked about the different kinds of insulation Jeff had thrown out there, right? So here's the mineral wool compared to EPS, XPS. This is the industry polyiso, but if you go with the product specific, we're all the way down here. So this is kind of the increase in embodied carbon. I'm curious if, when you guys are specifying any of these other types of roof insulations, but this is really the sustainable solution. And we see how quickly that adds up. All right, I have one more example I want to share with you. Was anyone at the AIA convention this year? And if you were, did you walk out of that convention center and there was this brand new building? It was almost done. It wasn't quite done. There were a few windows missing as they were finishing up construction. But this project is something really special. It's a commercial building up in Boston, and has some really cool goals, right? So it is very community-oriented project. It is office, it's lab, it's retail, it's community gathering, all rolled into one. But it had some very significant sustainability goals. It was focused on sites and LEED and WELL and the Boston stretch code all at the same time. So this is probably the most sustainable building in Boston in this moment. So they had to make some, design decisions. And my question to you is, does this look like a particularly amazing roof that you would put on a living building challenge project, right? Does this look like this incredibly sustainable roof? It looks like a conventional roof to me. So there are a couple things to note about this, right? We've got a concrete roof deck. So inherently we need that vapor retarder to manage the moisture. That's like a performance mandate, right? We're able to use the two layers of insulation between the flat and the tapered. The tapered was really interesting in that we had to really measure down to the fraction of an inch because of the FAA height limitations for the building. So that became an interesting exercise. The membrane is part of a stormwater management system. So that had to be accounted for in the project. And it was also supporting a solar array. So we had to think about all of these performance attributes that needed to come into play. And oh, by the way, we have all these sustainable attributes to hit as well. So how do we do that? How are we going to look at all of these parts and pieces and design an assembly that's going to meet all of these performance needs and all of these sustainable goals for this project? So this is how we really can leverage the material pledge impact categories to walk through all of these choices that we have. So again, we've got our third-party verified ingredients, recycling content, we've got our product-specific EPDs, we've got our resiliency with the cover board that's in there. How would you improve this assembly? What's missing? So again, that NH-ISO goes a long way, and that again at a no cost there. So we were able to, those are elements we can capitalize on. But I love that this project focused on utilizing TPO as the roof membrane. And there's a lot of really great attributes with TPO in general. TPO is red list free, right? So we don't have to worry about those elements that we do with other roof membranes and the trade-offs that we need to make there. But the premium grade TPO, not the standard grade, but the premium grade TPO also complies with NSF P151 for potable rainwater catchment. So that was really leveraged. It's also a higher performance grade. And so as you're looking at roofs that have that solar capacity that are really going to be baking in UV to a greater extent, the long-term performance of these premium grade TPO materials is really the right way to go. So we got a 2-for-1 here. We got the performance and the sustainability attributes all embedded into one material. But we can't do that without the product-specific EPDs either. So that's kind of how this all ties together for us. Jeff, is there anything that you would add to that before we kind of wrap things up?
I think the only thing, kind of area where you can always find improvements there as well is, we've used TPO and reflective coatings at times for bifacial solar projects to get for a fraction of a cost more for the bifacial, the panels kind of on a rooftop, you get essentially nearly double the energy performance of that solar system. And, the reflectivity that enhanced TPO provides is kind of adds potential future benefits to that as well. Now, if that made sense for Boston, maybe, certainly in other parts of the country, it certainly has.
Great, thank you. All right, well, I wanted to make sure we left enough time for questions and conversations. So I just want to summarize. The whole point of this has been, what if your roof could be a bigger contributor to your sustainability goals at the same time while not breaking the bank? So let's make sure we're leveraging the resources available to help the project owners stop thinking that sustainability is expensive and start thinking that sustainability is smart. And a lot of that comes down to materials selection decisions and being really intentional about what we're putting in our specifications and requiring these product-specific certifications and third-party verified elements. And if making sure that you're requiring this documentation and make sure that you understand it. I saw in the chat somebody saying, well, yeah, sometimes we can't, get the EPDs and it makes it really difficult to verify the reliability of the LCA analysis. Okay, well then push on your manufacturer to help you with that, right? Ask them to disclose what isn't. I know we've fielded, some calls on, the nuances of things that they're looking for clarity on, and we're willing to sit down and partner with you and have those conversations and really help drive projects to make these sustainable choices. And awareness that in many cases, you guys are already doing the right things. And so knowing what to look for and what to ask for, not just EPDs, but product-specific EPDs, and the product-specific EPDs that are certified by NSF, right? Really taking it all the way through that scenario. Looking for HPDs, but the most current version, which I believe is 2.3. Is that correct, Jeff? So we want to make sure we're looking at that. Looking at the product life cycle. Is it cradle to gate? Is it cradle to grave? Is it cradle to cradle? And really looking at what the elements are embedded in those assumptions that make up the LCA. The green circle certified content, whether that's the recycled content, right? That's third party. That's not just a manufacturer saying, oh yeah, we do that. Like, this is verified information. And then of course the red list free materials, the declare label, and then looking for those products that have that lower embodied carbon. So to wrap it up, we know that there are materials available to support the material pledge impacts categories without additional project cost. And that, I think, is the big key to holding your beautifully designed projects and specifications. Looking for that third-party documentation whenever it's possible, and that's including that product-specific EPDs and the recycled content. And then the sustainable design choices require trade-offs, and we're always here to help you navigate those conversations, to help get that owner to stop thinking about sustainability, stop thinking about sustainability is expensive and start thinking that sustainability is smart. So we have time for a few questions, but I'd actually like to start with the first one. So if you guys want to put your questions in the chat, or I don't know if it's even an option to take people off of mute, but Jeff, I wanted to ask you a question. So as I wasn't able to dive too deep into the chat, but I did see a little bit when we were asking about EPDs and their availability.
Yep.
We had such a wide range of answers, which I thought was really interesting. We had, EPDs are available and often salient, to they're not really available to vet out the reliability of the LCAs, to we're not really looking for EPDs. So there's obviously a pretty wide spectrum going on, right? But how can our listeners find this type of information?
Yeah, it's a great question, Jen. And I would argue to say that everybody on this call, kind of an EPD is an added tool. It's an added tool for you to understand the environmental impact of the products that you're looking to spec into a job. And there is, I saw a couple in the chat here too. Sorry, I was perusing that too. And make sure that, an LCA is conducted on what's called a product category rule. That is defined by a body of experts on how the assessment for a product needs to be considered. Typically made up of practitioners, of academics, of researchers, and product experts. And so there's the strong foundation of LCA at individual product level is highly developed. And then the other critical piece of this is ensuring that an LCA is certified through a credible third party, like an NSF, like a UL, like a Green Circle. Sustainable Minds is another entity that does PCR and work, as well as LCA work. And make sure that there is a solid foundation so you can trust that data. Trust the analysis itself. essentially the EPD is just an external version or facing version, also vetted by kind of a critical reviewer like NSF or UL, that needs to have only trust those EPDs when they have that third party kind of accredited body kind of actually publishing that EPD. If it's just an EPD published by kind of a manufacturer, I think it's data that's worth asking a lot of questions about. I think even when it's certified by an NSF or UL or whomever, it's always good to dig in on the data. And if the manufacturer is a good partner with you, they'll sit down and talk with you about the data. We'll sit down and talk with you about the data as it relates to the environmental performance of our product. It's why we disclose all of this. It's the world of product transparency. Transparency is a foundation of building a better built environment in the future. And that's all based on the research and data that we do in our LCA work and the results associated with it. So Jen, I hope that answers your question. It certainly kind of probably opens the door for more questions, but we're happy to take those as well.
Yeah, we have time for a few more questions, but Andy, I'm hoping you could put in the chat our the resource that we have to sort through all the sustainable elements in our product line. That could be a useful tool to help realize what products you can utilize to gain different points.
Yeah, you can go, Jen, right to that point. I mean, you could go to, we call it our spec advisor. It lives right on our website. It demonstrates every product that we have that has some level of environmental product declaration or health product declaration, declare label, recycle content certification. And you can click right on it and get those documents right there. So we believe that equipping you guys with those tools right at your fingertips so that kind of you can dig in and say, hey, here's the global warming potential that we know compared of this product. And then if there's a need to dig in further, we can do that with you.
Great. Do we have any questions? All right, so here's
quiet crowd.
Yeah, well, you know, it's in a public forum that's being recorded. I respect that. My contact information is up here. So feel free to reach out, ask us some questions. We're happy to engage with you. Andy also put in the chat the team email address. So regardless where you are in the country or whether I'm traveling, you'll be able to get somebody at that email address to pick up and help you out with your project. We also have our survival guide up here, which has a bunch of information on all sorts of technical resources for roof design and performance. So feel free to check that out as well. But really, thank you so much for this opportunity.
Thank you, everyone. And we'll be following up with some links as well. And please do check the YouTube channel because this will be up there so you can share with your peers. And we'll be following up if you have any questions you think of later. Thank you so much, Jennifer and Jeff.
Thanks, Melanie.
Thanks, Melanie. Thanks, everybody.
Yep. Thanks, everyone. Bye.
Bye.